Assalamualaikum warahmatullahi wabarakatuh. My name is Alif Najmi bin Ahmad Tamizi, DE200112. So now I will start our project presentation. That is a off-grid photovoltaic system. So my group is from group 4. So the task that have been given to us is as a consultant engineer, our team have been prepared a proposal of an off-grid photovoltaic system for a residential house that belongs to Mr. Ahmad Nisfu. So we create an environment issue for Mr. Ahmad Nisfu. So the issue that been faced for Mr. Ahmad Nisfu is that his residential is in the interior and far from the city and other residents. And the second issue is that frequently Mr. Ahmad Nisfu frequently experience power outages. So because of Mr. Ahmad Nisfu residential connect to the grid, so he needs to relay 100% to the electricity source from the grid. However, it's quite hard for him because this type of issue. With this issue, we came up an idea to help him by install the off-grid photovoltaic system. And the system will generate an electricity by using solar panel that absorb the sunlight. So this can solve Mr. Ahmad Nisfu issue. So the introduction of this project and is end of grid PV system refer to an installation that is not connected to the electricity grid. So this means that all the energy produced is stored and used on site. Essentially, off-grid photovoltaic system operate from the energy stored in the battery bank. Solar energy has enormous potential for supplying energy to our daily life. According to the researcher, the quantity of sunshine that touch the Earth's surface is in an hour and half is enough to power the entire planet for a year. Solar power is one of the most cost-effective and environmentally benign renewable energy technologies available. The off-grid house roof project will rely entirely on solar energy. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafiq Akal bin Suradi. My main case number is DE200055 and I'm from Group 4 Section 5. So today I would like to present about the off-grid photovoltaic system design via manual approach. So off-grid system are also called self-contained system or mini grids that can generate power and run appliances on their own. Off-grid system are also suitable for electrification of small communities. So this project is considering the feasibility of having an off-grid PV system that can be used for power supply for Mr. Nisfu's home. So site assessment. First step in designing an off-grid Mr. Ahmad Nisfu house would be find a suitable house appliance to install the panels. Secondly, how much solar panel that we need to install to Mr. Ahmad Nisfu house based on his appliance. So for this reason, we have to choose some appliance that's suitable to the solar panels. So this is the our sketch, which is we install the solar panels on the rooftop of Mr. Ahmad Nisfu house. And then this is the sketch that all appliance and the total load in this house. So next is the load analysis. So the unit that we have to use is watt hours. So the formula is watt hours equal to power rating in watt times duration in hours. And then we calculate by adding the individual load demand of each appliance per day. So the total energy demand, which is watt hours, equal to total power rating in watt times duration in hours. And then next is the power, formula. Power times quantity equal to total power times duration, which is equal to power consumption unit watt hour. So this is the equipment. Firstly, tube light. The power is 40 watt, the quantity is 6. So we multiply, we will get the total power 240. So the duration is 12 hours, and power consumption we multiply, we got 2880 watt hours. Next is bulb light. So power is 15, the quantity is 4, total power is 60, the duration is 2 hours. So we multiply, we will get the power consumption, which is 720 watt hour. So we use the same calculation to the each equipment until the station 5, and we will get the total power consumption watt hour is 13,140 watt hour. That's all for me.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iman Aiman bin Muhammad Din from Group 4, and I will present about the sizing calculation for solar panel, battery bank and the inverter. First, we have the sizing of the solar panel. So the daily consumption power is 3140 watt hour. The sun peak hour is 5 hours and the efficiency factor is 1.3. So to calculate the PV power, the total PV power, daily consumption divide by sun peak hours multiply by efficiency factor, and we got 3416.4 watt. This is the total of the solar panel. And to determine the number of PV panels needed, we will need the total of PV power divided by the power of one solar panel, and we got 8.99, and we round up as 9 panel. Next, the sizing of battery bank. So to determine the battery bank capacity, we need daily consumption divided by DOD multiplied by efficiency multiplied by system voltage. The DOD is 0.5, the efficiency is 0.85, and the system voltage is 48 volt, and we got 644.12 ampere hour. And then the number of string is battery capacity over battery rating, and we got 2.58, we rounded up as 3. Number of string is 3, and the number of series is system voltage over VR. We got the number of series is 4. So number of string is the parallel connection, so we have 3 parallel connection line up, and for the number of series is, for the one string we have 4 connection of batteries. Then we move to the sizing of inverter. The formula is load multiplied by 125%. So the table shows the load, and we have to multiply all the load by 1.25, and the total load we will get 2656.25 watt. So the best inverter, the most suitable inverter is rated by the power 3 kilowatt, the voltage 48 volt, and the current 60 ampere. This is the best the sizing of inverter needed for Mr. Ahmad Nisful house. And that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is Muhammad Izzat Imran. Today I want to talk about the sizing of the solar charge controller. Okay, solar charge controller, we assume the rating which the solar charge control is Vmax is equal to 530 volt, and the current is 60 ampere, and we assume the solar panel is a power equal to 380 watt, and VOC is 48.8 volt, and current is 9.94 ampere, and efficiency is 19.5%. We assume the component to design the PV solar system. When we assume the component, we need to calculate to approve we use the component is right. First, solar panel connection series and string. Number of series, Vmax is Vmax per VOC. Vmax is 50 volt per, and VOC is 48.8 voltage, equal is 3.07. It means is the series is we take is 3 series. After that, we need to calculate the string. Number of string is equal to number of PV panel per number of series. Number of PV panels we calculate. We done calculate this. Number of PV panel is 9 per number of series. Number of series is we have 3, and we get a 3 connections in parallel. And number of string is 3 and number of series is 3, and the coordinate of the solar panel like that, in parallel and series have a 3, in parallel have a 3. For the current is current CC equal to ISC multiply the number of string multiply the efficiency 1.25, and we get a 37.275 ampere, the less than ICC. And after we calculate, we have we prove the solar charge controller is good for the design. After that, this is a last for design. Is we design the solar PV solar system for the Encik Nisfu house. First, the solar is have a 9 plate panel solar, and have a 3 series and 3 parallel. Is connected to solar charge controller. After solar charge controller, we connected the battery. Battery have a 12 battery. 12 battery is coordinate is 3 strange and 4 series. After that, battery is connected to the inverter. Inverter is DC to convert the AC to supply the house load. Encik Nisfu Ahmad Nisfu. This is a design Encik Ahmad Nisfu house for PV solar panel. Thank you.
Assalamualaikum. My name is Fidos bin Talib, and today I'm going to present the last part of this project, which is discussion and conclusion. We start first with discussion. Okay, this slide is a list of solar power system equipment. We have 4 equipment. First, solar panel, 9 quantities, and function to source of energy to generate direct current electricity. Second, solar charge controller, we have 1 quantity. The function is to keep battery from overcharging. The battery we use 12 in quantity. It is used to store the energy to power your home when your solar panel do not generate enough electricity, which is at rainy day or cloudy days. Okay, lastly, the inverter. Inverter function to convert the DC current to AC current. Second, cost for solar installation. We have 6 components. First, solar panel. Second, inverter. Third, solar charger controller. And fourth, PV cable double core. And lastly, the battery. So, the total cost for solar installation is RM4,489.30 sen. So this is the total cost that Mr. Nisfu need to pay for this solar installation. Okay, the third slide. This is of advantage of solar energy. First, reduce air pollution. Fossil fuel create a lot of pollutant. Solar panel help get rid of air pollution. Your solar panel create clean energy that will contribute to air pollution. Second, improve humanity health in the long terms. We have already mentioned how the US Office of Energy Efficiency and Renewable Energy believe that a solar system can help us reduce water scarcity. In fact, they estimate that we could save more than 25,000 lives. That's because with the cleaner air comes cleaner lungs. And lastly, the advantage of solar energy is help fight climate change. Solar energy is one of the way we can try to prevent the effects of climate change by reducing our CO2, which is carbon dioxide emission, and releasing fewer pollutant in the air. We can all do our part to slow down climate change. And lastly, the conclusion. In conclusion, with energy costs consistently on the rise and with continuing concern about the environment, homeowners are seeking new energy solution, which is off-grid photovoltaic system were initially used in remote village, farming area, and houses. For this project, the owner named Encik Nisfu want to build an off-grid photovoltaic solar system to be delivered to all the equipment and accessory all over the house. It is because he wants to self-sustain his own electricity energy without relying to any currently established institution. That way, he can save a lot of money from paying electricity bill every month. He also does not have to worry about sudden power loss that always happen as he has his own supply of electrical energy. Other than that, the maintenance for solar power system is not that expensive and easy to care. Lastly, this solar power system really have many advantages and can protect the earth from pollution. I think that's all for me. Thank you.